Hello everyone, my name is Mark Aldrin Salakop, and today I will be explaining to you electromagnetic waves. So, what are electromagnetic waves? Electromagnetic waves, or EM waves, are energy that travels through space without a medium. Made of electric and magnetic fields, they result from the acceleration of charged particles. Electromagnetic waves use the spectrum called electromagnetic spectrum. The electromagnetic spectrum includes radio waves, microwaves, infrared waves, visible light waves, ultraviolet waves, X-rays, and gamma rays. Now that you've learned what is electromagnetic waves, let me show you how to formulate them. For the formula of electromagnetic waves, you will need wave speed, which is V or C, frequency, which is F, and wavelength, which is this sign. So, wave speed equals to frequency times wavelength. And frequency equals to wave speed divided by wavelength. Wavelength is equal to wave speed divided by frequency. The unit of measurement of these three, wave speed is meters per second, frequency is hertz, and wavelength is meters. If there is no given wave speed, the automatic calculation of wave speed is equal to 3 times 10 raised to 8 meters per second, which is the speed of light. Now that I've showed you how to formulate them, let us start the equating. For our first example, we have here, what is the frequency of a wave with the wavelength of 6.5 times 10 raised to negative 7 meters? Now then, follow me and let us equate. Now then, before we start equating, we must identify the given, unknown, and formula. The given is the wavelength, which is 6.5 times 10 raised to negative 7 meters. And the wave speed is equal to 3 times 10 raised to 8 meters per second. And the unknown is the frequency. So the formula that we will be using will be frequency is equal to wave speed divided by wavelength. Now, we can start equating. So, substitute frequency is equal to 3 times 10 raised to 8 meters per second and 6.5 times 10 raised to negative 7 meters. Cancel the meters, and the answer we will get will be 4.6 times 10 raised to 14 hertz. This would be the answer of the equation. Now then, let's move on to our next example. We move on to the next. For example number 2, we have here, what is the wavelength of a wave with the frequency of 3 times 10 raised to 18 hertz? So just like before, we must first identify the given, which is frequency that equals to 3 times 10 raised to 18 hertz, and the speed of light, which is 3 times 10 raised to 8 meters per second. And the unknown will be the wavelength. The formula we will be using will be wavelength is equal to wave speed divided by frequency. Now we can start substituting. So wavelength is equal to 3 times 10 raised to 8 meters per second divided by 3 times 10 raised to 18 1 over S. we change hertz to 1 over s so that we can cancel out the sign of the speed. So now we get 1 times 10 raised to negative 10 meters. This will be the answer of this equation. Here we have find the longest and shortest possible frequencies with the wavelength ranging from 2 times 10 raised to negative 8 meters and 3 times 10 raised to negative 3 meters. Let's go and formulate.
Go.
First, we identify the given, which are first wavelength, which is 2 times 10 raised to negative 8 meters. Second wavelength being 3 times 10 raised to negative 3 meters. And the wave speed being 3 times 10 raised to 8 meters per second. The unknown will be the longest and shortest frequencies. The formula we will be using will be frequency is equal to wave speed divided by wavelength. First, we will use wavelength 1. So, F equals to 3 times 10 raised to 8 meters per second over 2 times 10 raised to negative 8 meters. Cancel. And the quotient will be 1.5 times 10 raised to 16 hertz. Now, we move on to calculate the second wavelength. So, F equals to 3 times 10 raised to 8 meters per second divided by 3 times 10 raised to negative 3 meters. Cancel again. And the quotient will be 1 times 10 raised to 11 hertz. As you can see here, because 1.5 times 10 raised to 16 is the bigger number, it will be the longest frequency. And 1 times 10 raised to 11 hertz will be the shorter or shortest. Frequency. Now that we've answered this equation, let's move on to the next. Now that we finished this equation, let's move on to the fourth example. For the fourth example, we have find the wavelength of the wave with a frequency of 2.3 megahertz. Let's go equate. Identify the given with the frequency being 2.3 megahertz and the wave speed being 3 times 10 raised to 8 meters per second. Before we can equate, we must first turn megahertz to hertz. So, 1 megahertz is equal to 1 times 10 raised to 6 hertz. That means when we convert 2.3 megahertz we get 2.3 times 10 raised to 6 hertz. And now we can find the unknown, which is wavelength, and the formula will be wavelength equals to wave speed divided by frequency. Now we can equate. So wavelength is equal to 3 times 10 raised to 8 meters per second divided by 2.3 times 10 raised to 6 1/2. And the quotient will be 1.3 times 10 raised to 2 meters. And the answer will be 1.3 times 10 raised to 2 meters. Now we can substitute. So wavelength is equal to 3 times 10 raised to 8 meters per second and 2.3 times 10 raised to 6 1 per second. Cancel, and the quotient will be 1.3 times 10 raised to 2 meters, and that will be the answer. Now we can finally move on to our final example. In this example, it says, identify the frequency and the type of wave with the wavelength of 2 times 10 raised to negative 4. First, we identify the given, which is the wavelength being 2 times 10 raised to negative 4 meters, and the wave speed being 3 times 10 raised to 8 meters per second. The unknowns will be the frequency and its type. The formula we will be using will be F equals to C over wavelength. And now we can substitute. F is equal to 3 times 10 raised to 8 meters per second over 2 times 10 raised to negative 4 meters. Cancel, and the quotient will be 1.5 times 10 raised to 12 hertz. And by using the electromagnetic spectrum, we can identify that 1.5 times 10 raised to 12 hertz is equivalent to an infrared wave. Which will be the answer. Okay, now that will be the end of the presentation. Thanks for watching and have a great day.